Hello students. So today's topic is potassium permanganate, another salt of oxoanion of transition metals. Last time we have discussed about potassium dichromate. Hope you have gone through the properties and remember the important points. Do remember those points. Now potassium permanganate, it is prepared from pyrolusite ore. Pyrolusite ore is manganese dioxide. Okay. So preparation on treating or on fusing this manganese dioxide with alkali metals, hydroxide, that may be potassium hydroxide, and some oxidizing agents like potassium nitrate. As a result, the reaction is that is 2 moles of this manganese dioxide are treated with 4 moles of potassium hydroxide in the presence of oxygen. As a result, a dark green color K2MnO4 is produced. This K2MnO4 is called as potassium manganate. We call it as potassium manganate, and water is produced. So potassium manganate, it is dark green. Then this manganate is acidified, right? And as a result, we will get permanganate along with MnO2 and water, right? So this K2MnO4, it disproportionates in a neutral or acidic solution to give permanganate. So this is how permanganate is prepared, right? Then there are some other methods also for the preparation. Commercially, it is prepared by the alkaline oxidative fusion of MnO2 or manganese dioxide followed by the electrolytic oxidation of manganate 6. Okay, so as you can see, this is manganese dioxide. It is fused with KOH oxidized with air or KNO3, so we will get manganate ion. This we have already done. And then this manganate ion, electrolytic oxidation in alkaline medium will give you permanganate ion. So commercial method of preparation can be used. In laboratory, this is again important, the preparation of permanganate. For the preparation of permanganate, manganese 2 salt or ion is oxidized by peroxodisulfate to convert it into permanganate. As in the reaction you can see 2 moles of Mn2 positive ions and then 5 moles of peroxodisulfate ion. On hydrolysis or on treating with water, it will result in the formation of permanganate ion, then sulfate ions and hydrogen ions. Potassium permanganate forms dark purple, almost black crystals which are isostructural with those of potassium perchlorate. The salt is not very easily soluble in water. Just 6.4 grams can be dissolved in 100 grams of water, and that also at 293 Kelvin. But when heated, again this reaction is important, action of heat, it decomposes at 513 Kelvin. So potassium permanganate dissociates to manganate, potassium manganate, and MnO2 and oxygen is released. So this action of heat is very important, right? So these were the methods of preparation of potassium permanganate. Now after preparation, we will move towards the structure and properties of potassium permanganate. So manganate ion, as we have discussed, manganate ion is MnO4 2 negative and permanganate ion is MnO4 single negative. So permanganate ion is green in color and it is sp3 hybridized. Both are sp3 hybridized. Both have sp3 hybridization and structures will be tetrahedral. Just the charge, you can see that in this case its oxygen is acquiring negative charge. This oxygen is also having negative charge. So it is manganate ion and green in color. Whereas permanganate ion, it carries only just single negative charge. So Again it is tetrahedral and it is purple in color. So on the basis of their hybridization we can draw their structure. sp3 hybridized, so its geometry will be tetrahedral. Again the bonding you can see that in manganate ion 2 oxygen, because the 2 oxygens are carrying negative charge, so 2 oxygens will be double bonded with central atom, whereas in case of permanganate ion 3 oxygen atoms are double bonded, whereas one carries negative charge. Green manganate is paramagnetic, right? Paramagnetic, if you remember that molecular orbital theory, so as per that the electrons, when they are unpaired, one unpaired electron is there, but in case of manganate ion it is diamagnetic. So which one is paramagnetic? It's manganate ion, and diamagnetic is permanganate ion. Now the most important property of potassium permanganate, acidified permanganate solution oxidizes. So it acts as oxidizing agent. It acts as oxidizing agent, means itself it will undergo reduction, just like potassium dichromate we have discussed earlier. So during that such reactions, during oxidation, when it acts as oxidizing agent, it oxidizes oxalates to carbon dioxide. This will be doing in practicals. Okay, so it's oxalic acid. Oxalic acid gets oxidized to carbon dioxide. This we will discuss later also, and you have to remember this reaction. This is half equation, right? So 5 moles of oxalate ion are converted into carbon dioxide. There is oxidation of oxalic acid to carbon dioxide, or oxidation of carbon takes place. Okay, then in the same manner ferrous ions are oxidized to ferric ions. 5 moles of Fe2 positive and then Fe3 positive and 5 electrons. This again we will discuss in practicals, where with Mohr salt, when the titration, we will carry out titration with Mohr salt. Then nitrite into nitrates and iodide into iodine. So these are the important oxidation reaction or oxidizing agent, where KMnO4 acts as oxidizing agent. The full reaction can be written by adding half reaction that already we have discussed in redox reactions. KMnO4, half reaction of the reducing agent, balancing whatever is necessary. This all we have already discussed, so there is no need to go into detail. Continuing the same property, do remember that potassium permanganate or permanganate ion acts as oxidizing agent in 3 different mediums. The first reaction which is given, this is in alkaline medium, means with base, so it will be converted, that is permanganate ion is converted into manganate ion. E0 value is given, so this one will be in with alkali. Then the second reaction, MnO permanganate ion, it is in neutral medium, so it will be converted into manganese dioxide. Just to check the oxidation state, in permanganate the oxidation state is +7. In this case the oxidation state is +7, whereas in this case oxidation state, that is manganate ion, oxidation state is +6 oxidation state. Okay, that is in neutral conditions. Permanganate again +7 oxidation state, H positive ions, that is from water, or 3 electrons will be gained, so it will be converted into MnO2, where manganese gets reduced from +7, here +7 to +4 oxidation state in neutral medium along with water. So 1.69 is the reduction potential value, standard reduction potential value. Then the last one is most common, that is in acidic medium. So in acidic medium, permanganate ion gets converted into Mn2 positive ion, and 4 electrons are released. E0 value is +1.52 volt. Right? So hydrogen ion concentration in the solution plays a vital role, right? That which kind of product will be obtained after the completion of the reaction. Then permanganate should oxidize permanganate at hydrogen ion concentration 1 should oxidize water, but in practice the reaction is extremely slow unless either manganese ion, that is manganese ion, are present or the temperature is raised. So the reaction being very slow, as a result it can also oxidize water. Then in order to analyze the above properties, there are certain important reactions of KMnO4. Dear students, you have to learn these all. Direct question for balancing or completing the reaction may be asked from this. So iodine is liberated from potassium iodide. So 10 moles of iodide ions with permanganate ion in the presence of some hydrogen ions will convert, that is, this shows Mn2 positive is formed, so it is in acidic medium, right? Then ferrous ions are converted into ferric ions. 5 moles of ferrous ions, then permanganate ion, 8H positive, Mn2 positive. Again the reactions are taking place. All these reactions, they are taking place in acidic medium. In the same manner, oxalate ions, earlier we have discussed this. Then hydrogen sulfide is converted. Hydrogen sulfide is converted to sulfur. Just there are two reactions. So first the splitting is shown, and in second these sulfide ions, they are treated with permanganate ion in acidic medium to form Mn2 positive and sulfur. So sulfide ion is reduced to, this sulfide ion is reduced to sulfur. Then sulfurous acid, that is H2SO3, so it is SO3 sulfide ion plus permanganate ion, again in acidic medium, Mn2 positive. So sulfurous acid is converted, or sulfite is oxidized to sulfate, nitrite to nitrate. Note down these reactions and try to learn them. In the same manner, in neutral or faintly alkaline solution, there are certain oxidizing properties of potassium permanganate or permanganate ion. As you can see, iodide ion is converted into iodate. So do remember, this happens in either we can say neutral or slightly alkaline medium, right? Iodide is oxidized to iodate, IO3 negative, iodide to iodate. Then thiosulfate, H2S2O3 thiosulfuric acid, or Na2S2O3 salt of thiosulfate, sodium salt rather we can say. So thiosulfate is oxidized almost quantitatively to sulfate. Thiosulfate, it will be oxidized to sulfate. Again, practice these reactions. Written practice has to be done. Then the last one, that is manganese salt. Manganese salts are also oxidized to MnO2. This happens generally when it is totally in neutral medium. MnO2 is formed in the presence of zinc sulfate, or a zinc oxide catalyst carries this reaction. So these reactions are again important in neutral or in alkaline medium. So practice these. Now there is one important point: permanganate titrations in the presence of hydrochloric acid. Generally we carry out all the titrations, as we'll be doing in practicals, with sulfuric acid. So this question is asked that why hydrochloric acid cannot be used. So the reason is that hydrochloric acid, if we use this hydrochloric acid, so it will oxidize, it will get oxidized to chlorine. In addition to some other species, chlorine will also be formed in the reaction. So as a result, this is not selected or chosen as the better way to carry out titrations. Okay, so this was for the day.